along with the various features and functionalities this scientific tool provides. This tool allows user to design, analyze performance, and validate networks, and also permits the user to edit the network protocols. So why NetSim or any other network simulator? With the advancement of technology, newer protocols are being drafted, and it is really difficult to keep oneself updated with the latest happenings. Furthermore, analyzing the network behavior using traditional analytical methods or rules of thumb has really become cumbersome. It is not easy to manually analyze the network behavior, considering the fact the large number of parameters involved. Hence, network simulators or NetSim is used to provide an accurate understanding of network behavior and the associated problems and solutions. So NetSim is a scientific tool for designing and validating networks and protocols, and hence has a lot of use in protocol research and development, and in defense, for instance in simulating network-centric warfare scenarios. The wide range of technologies possible to simulate in NetSim are internetworks, which is LAN, WAN, wireless LAN, mobile ad hoc network, WiMAX, cellular networks, cognitive radio, LT, and wireless sensor networks. In NetSim standard version, users are provided with a C source code of network protocols, and these source codes are implemented based on IEEE and IETF standards. The purpose of providing this code is to enable the users to edit the standard protocol code according to one's own implementation, link it with NetSim, and analyze the performance of the newly designed protocol. NetSim has a huge number of customers, varying from enterprise, where it is used for network design and validation, to defense labs, where it is used for network-centric warfare simulation. It is also used in R&D labs for protocol development, new technology testing, and many PhD research papers are published by utilizing this tool. NetSim also has an academic version to be used in network labs of undergraduate curriculum and advanced network labs of graduate courses in electronics, computer science, and other related domains. Providing a holistic view of NetSim, users will design the network and configure it in a GUI interface, that is, there is no code, unlike other network simulators, and this network design will be then simulated by NetSim engine, and thereby, as a result, provide multiple metrics regarding the performance of the simulated network. The user is not required to write any script while designing and configuring the network scenario. Now, one striking feature of NetSim is this NetSim engine itself. As you can see it is utilizing a virtual network stack, which actually mimics the real-world TCP/IP stack. As a result, it makes it very easy for any user to edit the protocol and also get fairly accurate results. Furthermore, users can also perform research on cross-layer protocols like leech, where the user needs to simultaneously edit protocols of consecutive layers. So NetSim is divided into components or libraries. The standard version users can make a selective choice while using NetSim. This is a list of the contents of each library and the corresponding IEEE and IETF standards referred during implementation. Let's say, for example, the component 1, it consists of protocols implemented in wide area network, local area network, and wireless LAN. Like you can also see the standards, that is the IEEE 802.11 AB, GN, AC. Similarly, component 2 consists of network based on legacy technologies. Component 3 consists of BGP. Component 4 contains MANET and WiMAX. Cellular technologies are present as component 5. Component 6 contains wireless sensor networks, personal area networks. Component 7 contains cognitive radio networks, and LTE networks is present in component 8. Component 9 contains military radio, which is actually provided to enterprise customers. So in NetSim version 8, we have added new protocols like LTE and revamped the old protocols like BGP and cellular networks. Furthermore, new features like dynamic metrics, UI property view, and new application models like email HTTP has also been added. Other than this, we are presently working on NetSim v9. So the new features which will be coming up in the upcoming v9 version will be that IoT with IPv6 and sensor application will be coming. Along with that, mobile ad hoc network will have file-based mobility, and users can also interface NetSim with MATLAB. So now I will divide this demonstration into two sections. The first being explaining how to design and analyze networks in NetSim regarding wireless sensor networks. And in the second part, I will show you how to edit the wireless sensor network protocol source code and link it with NetSim. So to create a scenario in wireless sensor networks, users need to select wireless sensor network. Now, to assist the user, we provide an option where the user needs to provide the environment length. So by putting 50 meters, I'll get an environment of 50 into 50 meters. Now for placing the sensors, users have the option of uniformly placing the sensor. Like if I put 16 sensors will be uniformly placed over the grid. If the user wants, they can also randomly place the sensors. And in case if they manually want to drop each sensor, they can click on select via click and drop. So for the time being, I'll select uniform placement with 16 sensors. So you can see 16 sensors uniformly placed in the environment. Before proceeding forward, I would like to explain a few basics of wireless sensor network. So wireless sensor network is based on IEEE 802.15.4 low data rate wireless person area networks. So this standard is widely used because of its position independent sensing capabilities. The application of wireless sensor network is mainly area monitoring, forest fire detection, battlefield surveillance, enemy intrusion detection, and more. So devices in wireless sensor network. Wireless sensor network has mainly two types of devices according to the standard. The first one is full functional device and the second is reduced functional device. Let me start with reduced functional device. So devices are sensors which can only sense the object or rather the agent and send the information to the FFD, full functional devices, are actually reduced functional devices. But instead, full functional devices are those sensors or devices which can sense the agent as well and route the packets. So full functional devices have the extra ability to route packets among themselves. Also, they can initialize the network, like for example the wireless WSN sync node or the PAN coordinator. So just now, as I said, the sync node, it is also known as the PAN coordinator. It is the principal controller in the WPAN. So if beacon enabled mode is implemented, then the sync node will be transmitting beacons and slotted CSMSC algorithm will be used. So this I'll be explaining further. Other than the sync node, another device which is there is the agent or rather the object. So what happens is, let's say fire sensors, they are used for sensing fire. Similarly, a sensor will sense the agent or the object and it will generate a packet which will contain the position of the agent. So in NetSim, agent mobility is modeled by random walk and random waypoint, which is followed internationally to test wireless sensor network. The reason why agents require mobility is, for example, let's say fire. A fire won't be there statically located in one place, it will spread. And for each of these models, users can also set velocity and pause time. So the third kind of device, that is the sensors, is used. Let me go to NetSim and show you. So I have already placed the sensors. Now all I need to do is place the PAN coordinator or sync node and one agent. So the sensors will sense the agent and will send the information to the sync node. So this is a sample diagram. Now this scenario in wireless sensor network. So there are two kinds of topology which can be implemented as per the standard. So one is the star topology, where all the sensors will be directly communicating with the PAN coordinator. And in the peer-to-peer topology, the sensors may directly communicate with PAN coordinator or route the packets or the information via the other nodes, other FFDs rather. So before proceeding with the simulation, let me go to each of the device and check their properties. So if I go to sensor, so in the sensors, users can edit the maximum CAC back off, the maximum minimum back off exponents, the frame retries, and also they can edit the power and the sensor range settings. So let's say the user or the researcher is working on body area networks, or let's say health sensors. So the researcher can set the settings of the health sensor in NetSim and configure the sensors here. The same goes for environment sensors also. Other than that, the sensor range and sensor interval can also be configured manually. So sensor interval is how frequently the sensor will be sensing the object or the agent. And as told before, the agent will be having mobility models which the user can set and configure. So let me simulate it. So after simulation, the performance metrics window comes. So as you can see here, the network metrics, it allows the user to view the values of the metrics obtained based on the overall network. The link metrics, it displays the value of the metrics pertaining to each link, like packets transmitted, packets errored, collided. In wireless sensor network, we have only one medium, that is the wireless medium, hence we can see only one link. Then the protocol metrics will also display the protocol based metrics which are implemented in this network scenario. So here, as you can see, the IEEE 802.15.4 protocol is implemented. So the various packets received, transmitted, the clear channel assessments, the attempts, the total back off time, and you can see the beacon received, beacon forwarded, beacon time. The reason why it is 0 is I'll be explaining later. Other than that, the sensor metrics. So in using sensor metrics, users can analyze like a sensor, how frequently it has sensed the agent and what was the location of the agent. Next is the power model metrics. So it is one of the important metrics which shows how much energy is consumed for which purpose and hence whether the sensor is still alive or not. So other than these performance metrics, users can also view the packet animation. So packet animation enables the users to watch the traffic flow through the network for in-depth visualization and analysis. Unlike other network simulators, which only show the transmission of packets, NetSim goes a step further and displays some basic packet information like packet ID, the type of packet, and whether it is successfully transmitted or not. So you can see here the red colored packets. So this means the packet has collided. The green packet indicates a data packet successfully transmitted. And if you see any blue colored packet, it means a control packet is successfully transmitted, like just now. Also, if the sensors are having mobility, or let's say the agent is having mobility, users can also observe the changing location of the nodes. In case this here, the agent. So if I change the time, you can see here how the agent is changing the location. So as per the standards, there are two operational modes, beacon enabled and beacon disabled. So in beacon enabled modes, the PAN coordinator will periodically generate beacons and synchronize the devices within its network. Also, it will be using the slotted CSMSCA algorithm. And in case of non-beacon enabled mode, the device will simply transmit the data by implementing unslotted CSMSCA. So let us consider the beacon mode. So in case of beacon mode, as I've already said, beacons will be transmitted after every periodic time. So beacon frames occupy the first slot in the super frame. The super frame stands for the time duration from the first beacon to before the last beacon, I mean the consecutive beacon. So this whole is known as the super frame. The beacons are, as said before, used to synchronize the attached devices to identify the network, and it also describes the structure of the super frame. That is, how much will be the inactive period if it is there, how much time will the data be allowed to transmitted. Now, the inactive period. The purpose of this inactive period is to reduce the energy consumption of all the sensors. That is, during this time, the sensors along with the coordinator will go into a low power mode and they will stop interacting with each other. Hence, it increases the network lifetime. The active period consists of two parts, that is the contention access period and contention free period. The length of the active period is determined by the superframe order. So the active period length, as you can see, so in the contention access period, all the nodes having the packet would like to transmit, and hence they would compete for the channel. So this is performed according to the slotted CSMSCA algorithm. So, hello, Shravan, am I audible?
Here you are audible.
Okay, fine. So as said, the active period is divided into two sections. The one is a contention access period and contention free period. So in the contention access period, the sensors would have to compete for the channel, whereas in the contention free period, the PAN coordinator allocates the slots, which is also known as guaranteed time slots, and there is no contention among the nodes. Now, to determine the beacon interval or rather the time difference between two beacons and the active period, it depends upon two parameters. One is beacon order and the other one is superframe order. So using beacon order, the time interval between two beacons is determined, and it is also known as beacon interval. So this is the formula of beacon interval, A base superframe duration into 2 to the power BO symbols. So A base superframe duration is mainly around 15.36 milliseconds, and according to the protocol, the beacon order should lie between 0 to 14. The superframe order determines the superframe duration, that is the active period. And same, the formula is also A base superframe duration into 2 to the power superframe order. And superframe order should always be less than beacon order, as the active period cannot overlap with another beacon's active period. So let us go into NetSim and check. So to enable, by default beacon mode is disabled. The user can enable it, and as you can see, it provides the option of superframe order and beacon order. Now according to the protocol, if the superframe order and beacon order is set to 15, it is equivalent to non-beacon enabled mode. So we have to set some other value. So let's take 9 for both the cases. And let us simulate. So now if we go to the wireless sensor network matrix, let me scroll. So you can see here the last node, that is device 17, which is nothing but the sync node, has transmitted around 7 beacons, and hence the other sensor nodes have received the beacons, 7 beacons, and they have also forwarded it. And you can also see the beacon time, the CAP time. If you notice, in the power model matrix, the sleep energy consumed is 0. That is, there is no sleep. That is, the sensors are not inactive at any time. And the reason is simple. We have kept superframe order and beacon order as 9. That is, both are same. If both are same, then the superframe duration and the beacon interval will be also same, as you can see the formulas. And as the superframe duration and beacon interval is same, so you can easily understand that the inactive period is not present. So what we will do is, next, we will change the superframe order to 8 and beacon order to 9. Now if we go and check our power model matrix, you can see here sleep energy is consumed. Hence, there is the presence of inactive period when the sensors are going into idle mode, and even in the idle mode, a very small amount of energy will be consumed, which you can see here according to the values set. So sleep mode current is very less. So because of this reason, some amount of sleep energy will be consumed. So this is how you change the beacon order, you set the superframe order in NetSim. Next is the clear channel assessment. So the purpose of the clear channel assessment, or CCA, is for sensing the channel and deciding whether it is busy or idle. So it has three modes, or the three ways of performing. The first one is energy detection. So if the channel energy is less than the ED threshold, or energy detection threshold, then the sensor will report the channel as idle, or else it will report it as busy. The other way is the carrier sense mode. So the sensor will sense the medium, and if it detects a signal which is having same modulation and spreading characteristics of IEEE 802.15.4, then there is a chance another sensor might be transmitting signal. So it will consider the medium as busy. Now the third operational mode is the combination of the first two. That is, it will report the medium is busy if it detects a signal with the same modulation and spreading characteristics, as well as the energy when it is above the ED threshold, or the energy detection threshold. So in NetSim, for every sensor, to set the CCA mode, user needs to go to the physical layer property, and then they can set the CCA mode here. And they can also set the ED threshold value. So as per the standard, for beacon enabled mode, the slotted CSMA-CA version of algorithm is used, and for non-beacon enabled mode, the unslotted CSMA-CA algorithm is used. And I'm not going deep into the algorithm because of time constraints. So these are some of the values which are implemented in NetSim as per the IEEE standard 802.15.4. Now, the analysis which I have shown you, the performance metrics, the packet animation, this is present only in the this is present in both standard and academic version. The use of academic version, as I've already told you, is for network labs of mainly undergraduate curriculum students. But for protocol researchers to further have a deep understanding of the protocol and analyze the intrinsic details, we have some extra features. So in standard version, users will be getting packet trace, event trace, and dynamic metrics. So as said before, these academic and standard version both will have the performance metrics and this view packet animation. So the packet animation, as I said before, enables users to watch the traffic flow through the network for in-depth visualization and analysis. Now, for the standard version, users will be having packet trace. So NetSim allows users to generate trace files like this packet trace, which provide detailed packet information useful for performance validation, statistical analysis, and also custom code debugging. So packet trace logs this set of chosen parameters like the packet type, the control packet type, and the source, destination, transmitter, receiver, and so on. So whether the packet is successful or not, the time at which the packet reaches the physical layer, the MAC layer, and all the details. Again, NetSim is a discrete event simulator. So it provides event trace, which records every single event along with the associated information such as timestamp, event ID, event type, And more, in a CSV file, it is stored in a user-defined location. So users can easily analyze the way the protocol is working. For example, let's see here that after the network out and the MAC out here, and IEEE 802.15.4 protocol is being implemented. So you can see the DSR root request timeouts, then the beacon transmission end, and just before transmitting the DSR root request packets, it will be performing the carrier sense, that is the CSMAC algorithm. So you can see for transmitting the DSR root request packets to initially create the routes to reach the sink, and so on. Also in dynamic metrics, users can view or rather monitor the value of a parameter over simulation time. So in this case, the user can see the medium link throughput. So this was all about analyzing a network, or rather the wireless sensor network in NetSim. Now let's see the researcher who wants to edit the network protocol. So in NetSim we also provide a development platform which is there only in standard version. So the source C code of wireless sensor network is provided. Users can modify this code and link the code with NetSim. And users are also provided debugging using this code so that they can analyze whether their edited code is working correctly or not. And along with the code, we also provide a wide variety of APIs for, let's say, to create a packet in NetSim. Instead of writing a custom code, users can directly use this API and generate a packet. Same for copying a packet, that is duplicating a packet, deleting a packet, getting a device IP, and so on. So let me show you the source code. So as you can see, all the protocols like AODV, ATM, cellular, cognitive radio are already present here. So we will be going to wireless sensor network, that is ZigBee. So I'll be giving a demonstration now of how to edit the code linked with NetSim. So I will be making a very minor modification. So what I have done is, in the init function, that during initialization of this protocol, NetSim will print a hello NetSim text, and then it will wait for my command until and unless I press the button, and after this only it will start executing the protocol. So the steps of linking a custom code to NetSim is very simple. The first one is edit the code, which I have already done. The next step is to build the code. All the user needs to do is rebuild. So as you can see here, the code has successfully built, so my DLL is created. And next comes the third step, that is I have to copy this DLL into the bin folder. So now NetSim will call this modified DLL file. So if I now go and simulate, so you can see here before simulation, it is showing here hello NetSim in the last line. And because of getch command, it will not proceed. So I am pressing enter and it will start simulation. So this is it. It's very easy to edit the code in NetSim. And the protocol codes are based in C. So this is about NetSim and working with it. Also, I will be demoing a custom code that is Leech. So Leech stands for Low Energy Adaptive Clustering Hierarchy Protocol. So it is actually a cross-layer protocol. That is, the clustering is implemented in the network layer, and from the lower layers, the remaining power property is taken. This I'll be explaining later. So the goal is to lower the energy consumption required and thereby improve the lifetime of the sensors. So what I'll be demoing now is, there will be around 64 sensors with 4 clusters, that is each cluster containing 16 sensors. And as we know, the sync node is the primary controller in the wireless sensor network. Now in each cluster, there will be one cluster head, and its objective will be to collect data from surrounding sensors in that cluster, then pass that data to the base station or via the next cluster head to the base station. So for each cluster, there will be one cluster head whose first objective will be to obtain the information from the sensors of the cluster and then forward this information to the sync node. So the way the code is implemented for this Leech is that the cluster heads of the first 2 clusters will be forwarding it to the next cluster heads, which in turn will forward it to the sync node in this manner. So this was what actually the implementation. I'll be showing you the code. So Leech being a cross-layer protocol, the protocols I need to modify is ZigBee and DSR. So this is the code which we have modified, or rather added, leech.c. So here we are defining the clusters. Then initially we are statically defining the cluster heads. But with the passing of time, we will be assigning dynamic cluster head. That is, the cluster heads will be assigned with respect to the remaining power. The sensor which will be having the highest maximum remaining power among the sensors of that cluster will be elected as the cluster head. And then this is how the packets will be routed to the sync node. So all I need to do is now build these 2 codes, that is ZigBee and DSR. So you can see build all one succeeded and the earlier one also succeeded. So step 1, the code is already edited. Step 2, I just now build the code, and step 3 is copying the DLL. So now what I have to do is create a scenario. So I will be using 64 sensors, that is 4 clusters with 6 sensors each. So now when I start simulating, NetSim will be using the modified code. So now as you can see, the sensors are sending to the cluster head, which in turn is forwarded to the cluster head of this cluster. And then the packet or the information is transmitted to the sync node. So this is what is all about leech. Now we have over 300 plus customers across 15 countries, which spans from enterprises to the education domain and research institutes. So if you have any queries, you may ask now.
Are you having any queries, sir? Hello.
Hello.
Yes, sir. Are you having queries, sir?
Sir, is this software is useful for the student which are practicing CCNA, CCNP, CCIE?
Yes, but it is not a wireless sensor network. We actually have another domain called internetworks, so that will be useful. So, like wireless sensor network, we are also working. We also have other networks like the cognitive radio, the MANET. So we have internetworks also. That is the component one. So users can set the IP address, subnet masks.
Nirjar, what is the maximum number of sensor nodes in the cluster? This query.
Just a minute. In the research version, I think. I forgot. Yeah, in the research, that is the standard version. Users can have around like 500 sensors.
Okay.
But we also have a CLI mode, which can go like up to 65,000 nodes. Like 100,000 nodes you can easily put. Okay, the reason I'll also tell you, because the has a Java heap memory limitation, and if we are going beyond 500 sensors, it is creating some issues. It actually depends upon the user's RAM also. So we have limited it to 500. But if the user wants, there are techniques by which they can also increase it to some 1,000 or more.
Yeah. Any other queries? Yeah. If you have any query, you can ask us. Could you all hear me? Hello? 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 Sandeep Yadav, sir? Can you hear me?
Yeah, sir.
Okay. Do you have any query, sir?
No, sir.
Okay, fine, sir. Nirjal, there is a query. What is the work of leech?
So as I said before, it increases the lifetime of the network. So like if all the sensors are simultaneously trying to communicate with the sync node, it not only increases the congestion, but for the sensors which are far away, they need to have higher transmitter power in order to transmit the sync node which is far from it. So to avoid that, just a minute. So let me show you this scenario only. So let's say sensor A, it is relatively far from sync node and it may not directly communicate to the sync node. So it may hop, or rather to further control the sensors, clustering is done. And the advantage of clustering is the cluster head which is being selected, it is based on the remaining sensor power. So if any one sensor is being used multiple times to transmit the information of the other sensors, then it may happen that the sensor may fail very fast. So that is why dynamically cluster heads are elected. So the result is, if the network goes down, like almost all the sensors will be going down simultaneously instead of just one or two important sensors going down, which is in turn, turning off the whole network.
Okay. There is one other query. Can we specify the type of sensor in NetSim and configure sensor specification?
Yes, as I've already shown, users can easily configure the sensors. So the type of sensor cannot be configured. It's actually based on the parameters only. So if you need environment sensors, you have to specify the parameters accordingly. You can specify the routing protocol among the sensors, the settings of the sensors, and so on. And also the mobility, if you want the sensors to be mobile.
What are the power sources?
Yes, so as per the standard, the sync node will be mains powered. As you can see here, the sync node is main powered. But for the sensor, users can use battery powered as well as mains powered. The choice is given to the user. As I've said before, if you are implementing sensors of any specific type, which is mains powered, you can also set it. And if you are setting it as a battery powered, you can also perform energy harvesting. Let's say the sensor is having a solar cell above it. So you can turn the energy harvesting on or to off. So depending upon the type of sensor you are using, you have to set the parameters here.
Okay, any other queries? Neerja, there is one query. Which topology can be used for agriculture application?
Once again, the question, please.
Which topology can be used for agriculture applications? Agriculture applications.
So actually, I would say it depends upon the implementation. So, like, if it is a smaller area, you can use star topology. If it's a huge area, then mesh topology is always preferred. Upon again, depending upon that, if the sensors are mobile, then you can use. Usually, it is static, but in case if you are implementing mobile sensors, then you have to decide the routing protocol also, and the density of the sensors. So it depends upon a lot of factors. You cannot just tell that in agriculture sense. I mean, in case of this one single domain, one single protocol, or one single topology is perfect.
Okay.
Depends upon a lot of parameters.
Okay. Any other queries? If you do not have audio facility, you can write your queries to us in chat box or in query, or you can mail us also. Any other queries, sir? There is one query, Niger. How CR setup can be implemented using NetSim cognitive radio? I think.
Okay, for cognitive radio, I'll be showing tomorrow, but I can show you, I can just give a sneak peek.
Just small.
So we have also cognitive radio networks. So users can put the base station, they can put the CRCPE, that is cognitive radio customer premise equipments, then the primary user, then they can put routers, the wired network, the backbone network, and then they can connect them. And accordingly, they can also set the properties like the frequency of the primary user, the bandwidth of the secondary user, the channel bandwidth as per the standards, and also. So I'll be explaining this in details tomorrow.
There is one more query, Niger. With respect to CCA, can just tell me its three modes of operation once again.
Sure.
With respect to CCA.
Sure.
Hmm.
So you need to explain the CCA mode, right?
Yeah, it's modes of operation, 3 modes of operation.
Sure, sure. So actually CCA or the clear channel assessment is used for sensing whether the channel is busy or idle.
Hmm.
So depending upon the CCA is performed and there are 3 operational modes as you can see on my screen. The first one is the energy detection mode. So we have an energy detection threshold. If the channel energy or the medium energy is less than the energy detection threshold, so it is considered that the energy which is obtained is actually noise and not a signal transmitted by some any other sensor. And hence it will be reported that the channel is free or idle. In case of carrier sense mode, the sensor will sense the medium and if it detects a signal which has the same modulation technique and the spreading characteristics like that of the IEEE 802.15.4. So then it can consider that, okay, there is a chance that some other sensor might be transmitting the signal. That is why I am detecting a signal with the same modulation and spreading characteristics. And hence, it will consider that the channel is busy or the medium is busy. And the combination of these two is the third one. So here what it will do, it will check whether the energy of the medium is above the ED threshold. Also it will detect the signal, whether the modulation and spreading characteristics is matching. If both of them are successful, that yes, it is matching and it is above the ED threshold, that means for sure some other sensor is transmitting signal and hence the medium is busy. So these are mainly the 3 operational modes.
Hmm. Okay, sir. Any other queries? Okay, sir. Then we end this presentation for now. But tomorrow also there is another session. If you wish to join for some other discussion, you can join tomorrow also. Thank you everyone for joining.